Hello, welcome back. Today we are going to be taking a look at area volume question here. And this is from the A/B test, but it's a really good one to take a look at. It says, let f and g be defined by the following functions. Let f of x equal this natural log of x plus 3, and g of x is this x to the fourth plus 2x cubed, and they give us the graphs below. Oh, how nice. They tell us that they're going to intersect at -2, and at x equals b, where some b is just some unknown value, but it's greater than 0. The first question says, find the area of the region enclosed by the graphs of f and g. So for part A, it's pretty easy to do. I'm looking just for this area, so I can kind of shade that in if I wanted to. And I can draw my rectangle of mathematics, and there's my rectangle of mathematics. And if I blow it up down here, there it is. We know it's dx thick, and don't forget to get the length, top minus the bottom. So our top function, it looks like it's going to be the natural log function right here. So the top is going to be this f of x function, or the natural log of x plus 3 minus this x to the fourth plus 2x cubed. You can leave it like that if you like. And so let's see here. So if I wanted to get the area of this, it's going to be, let's see here, length, which is this natural log of x plus 3 minus this x to the fourth plus 2x cubed times the width, dx. Remember, it's length times width of our rectangle. So you have the length and the width that they give you. Remember, and the width is really tiny skin. Oops, sorry, it's this little bitty, tiny little bit of a rectangle right here. Now we need the bounds. Now what's nice about this one, to get the bounds, they already gave us one of them, but we have to find out where it does f of x equal g of x. We need to find their intersection. They already tell us one of them is -2. So I just have to find the other, and that's what our calculator is going to be for. So let's see here. I'm going to graph these. Whoops, clear that out. Let's go to my graph. If I graph the first function, it is the natural log of x plus 3. Enter. Enter. There we go. And I'm going to graph the second function, which is this x to the fourth plus 2x to the third. And I graph that. And I want to find out, of course, where these meet. That's the intersection. Go to Menu, look at Analyze Graph, and I'm looking for that intersection. Go Enter, and I'm just going to scroll here. Now, let me see here. And it gives me 0.782, and that's what I'm going to use. So we get this 0.782, and that's what I put up here, 0.782. And now to get the actual area, so I would get +1 here, probably +1 for the bounds as well. Let's see, you get the answer, Menu, and I go to home screen, Menu, 4, we're looking for the integral, 3, and I just type in my bounds, -2 to 0.782, and I type in my function. Exactly as it looks, the natural log of x plus 3, minus, in parentheses, x to the fourth, plus 2x to the third. And don't forget your differential, the dx. Press enter, and we get this 3.06035, and on the AP, don't forget we want 3 decimal places, 604 is what we would put. And there's our answer. There's part A. All right. Now for part B, it says between -2 and b, let h of x be the vertical distance between the graphs. We already got that. That is our rectangle of math. Is h the height increasing or decreasing? This sounds like, to me, a first derivative. And that's exactly what we're going to do here. So, remember, for the AP, it's one thing to know the calculus, but it's another one to show it. So they're looking at the h of x. They say h of x, let's go back up here again, h of x is the vertical distance between f and g. So I'm going to write those out. The vertical distance, so h of x will equal, so I got to go up here. We know from here f of x is our natural log, so that's our top function, and of course our bottom function, of course, is g of x. So if I go down here, this is just going to be f of x minus g of x. And what we want to find out for part B is the distance between them increasing or decreasing at -0.05. So I need the derivative. And I'm going to take the derivative. Before I type in anything, I am going to physically write out that derivative right here. And now all I have to do is plug in my 0.5. H prime of 0.5 is equal to f prime of, negative 0.5 there. Sorry about that. Negative 0.5 minus g prime of negative 0.5. And I already have it graphed, and that's what the calculator is really good for. Here's my graph. I'm going to go ahead and sorry, no, don't want to do that. Escape. Just delete some of these things here so it's a little easier to see. And now I'm going to find the derivatives. So a quick way to do it on the graph, menu, analyze graph. I want to find the derivative at negative 0.5. Now tell me which graph. So I'm going to highlight the blue. That is my f of x function. And I just type in negative 0.5. Let me see if I typed it in right. Doesn't look like it. So negative 0.5. I press enter. And it gives me 0.4. So I go 0.4 minus, and now I'm going to do the same thing for g of x. Analyze graph, looking for that derivative. Pick my function. So I'm going to pick the g of x function, or the red one in this case, and I just type in negative 0.5 again. And this time it gives me 1. So 0.4 minus 1 right here. And if I simplify this, that's going to give me negative 0.6, which is less than 0. So therefore, we can say that this distance between them at that point is decreasing. So therefore, h of x is decreasing at x equals negative 0.5. Now, another way we can get the derivative, we can go to our home screen, homies, and we can just go menu, 4, 2. And I'm looking for my x value, and I just type in here, negative 0.5, press enter, and I can type in my function. The first one was, of course, the natural log of x minus 3. I press enter. Oh, this time it gives me this negative 0.3. So something must have happened. So let me see here. Let me go ahead and fix that. So this was my first one right here. And let me try the next one. Interesting. I didn't think that was right. I think somebody was having trouble with that. And then the other one was our x to the 4th plus 2x to the 3rd. Press enter, and that gives me 1. So I must have typed in the first one wrong, and that gives me a negative 0.2. So, and that's okay. Luckily, I checked it, and honestly, a mistake like that is really hard to find unless you double check it. So that should have been a negative 0.285, which is going to give us a negative 1.285, which again is less than 0. So in either case, it does, hold on. All right, I'm going to correct it one more time. All right, so as many of you guys noticed, I probably typed in x minus 3 to the x plus 3. So my original 0.4 was correct. So I am going to erase all this bad stuff and just make sure it looks correct. So yeah, so that's okay. Mistakes happen. Heck, I'm on video. If I knew how to edit this, I would look much better. But still less than 0, so it's going to be decreasing. All right, so let's take a look at part C here real quick. Now, part C says, the region enclosed by the graph is the base of a solid. So the cross-section of the solid taken are perpendicular to the x-axis. That means we are in terms of x, are squares. So if I take that same region now, and I'm going to kind of graph it out here. If we take our same little region here, remember it kind of looks like this, right here. Now we're taking these little cross-sections, our little rectangle of mathematics, and from here we're going to build a square. So we're going to build so this is our base of our rectangle, and from that base I'm going to build a square. And again, this is just going to be f of x, so the natural log of x plus 3 minus this x to the 4th plus 2x cubed, right here. Now, so this is a square, so I want to get the area. Well, the area of a square is just s squared. So that's just going to be this natural log x plus 3, natural log x plus 3, minus this x to the 4th plus 2x cubed squared. Now, to get volume, I would just take that base and I would multiply it by the height. Well, the height of this rectangle, remember, it's a really skinny little rectangle. The height is our dx, always. Height's always dx. In this case, because we're in perpendicular to the x-axis. And again, I would just integrate that from our domain. -2, and what was it, 2? 0.782. 0.782. Now, do they want us to solve this one here? They do say find the volume. So once I'm here, I'm just going to type it in my calculator. So I'm going to graph it. Menu 4.3, my integral. And I'm just going to type it in exactly as it looks here. So let me take a look here. We're going to go -2 to 0.782. And if I type this in here, parentheses are very important now. Natural log of x plus 3 minus, in parentheses again, x to the 4th plus 2x to the 3rd. Now be careful, we got to square all of that this time, dx. Press enter, and we get 5.3401. We'll go to 3 decimal places, so 5.340. And there's your answer. Yep, don't circle your answers, never box them in. All right, part D, we're mathematicians. We love to part D. So let's take a look here. Part D now says the following. A vertical line in the xy plane travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross-section above the vertical line with respect to the time when the vertical line is at -0. Alright, so this will be a fun one. So remember, to get the area, we're going to write our new formula here. Our area will be the following. H of x plus 3, well, natural log, I can't read my own writing, remember that was natural log, not h, natural log x plus 3 minus x to the 4th plus 2x cubed squared. So we want to find, let's take a look up here again, we want to find the rate of change of the area of the cross section. So we above the vertical line with respect to time. So let's see here. So we have to take this derivative. So here we go. dA dt is going to become 2 times the natural log of x plus 3 minus x to the 4th plus 2x cubed to the first times. Now the derivative of the inside, we got this 1 over x plus 3 plus over here we get this 4x cubed plus 6x squared. Now be careful, this is implicit. We're taking the derivative with respect to t, so it's a related rate, so we're going to multiply everything by dx dt right there. And at this point we just type in everything. Okay? So let's see what we got here. What do they tell us that we have? They tell us that x is equal to -0.05 and it's moving along the vertical line at a constant rate of 7 units per second. So they're telling us, so for here, they're telling us, given x is equal to -0.5 and dx dt is 7. And I'm just going to plug all that in, and I'm going to cheat a little bit. I'm just going to give you guys the answer. When you type all of that in your calculator, you get this -9.2718, which is going to be, of course, we're going to go to 3 decimal places, -9.272. All right, and in terms of units, this is going to be units, if you need to, units squared per second. All right, that's not the best one. I don't think I like that one that much. All right, hope you guys enjoyed the video. I'll see you guys soon. Bye-bye.